Okay, so in the last video, we have discussed about how to do the thermal decomposition of ferrous sulfate, which is blue in color. And now we will start with decomposition of lead nitrate, which is white in color. So what I have done, I have taken a lead nitrate in a test tube, white color lead nitrate. So as soon as you start heating it, there will be some changes which you'll observe, and you'll observe the change in color. Lead nitrate, which was initially white in color, will start changing to yellow color lead oxide, and even you can see brown fumes are being observed from the test tube. And even you can observe one more technique from here, that is the glowing splint. It reignites, that means it catches fire. So I hope all of you know that which particular gas helps in combustion. So that is oxygen. So what is the first observation that we observe? The color change. That is the white color lead nitrate is changing to which color? Yellow color. So now since this is a white color powder, we say the formula is PbNO3 whole twice. But in case initially you are using a colored powder, suppose you are using copper sulfate, so it will have initially a color. Why? I have told you in the last video also. Why? Because what happened? Why? Because there is a presence of water molecules. That is why we write the formula as CuSO4.5H2. But if there are no water molecules present in a particular compound, you can say the color of the compound will be white. So you can observe the color change now. Color change slowly you will observe. It will change to yellow color lead oxide. Formula for lead oxide is PbO. And ultimately you will find some brown fumes. So that will be our second observation. That is brown fumes. Brown fumes are being generated. You can say brown fumes are observed. And the glowing splint reignites is the third observation. Okay, so how many byproducts are formed from the observation? We can say that there are three byproducts. One is yellow color lead oxide, second is brown fumes of nitrogen dioxide, and third is oxygen, which can be justified with the help of glowing splint reignites. Now you can observe this lead nitrate. Initially it is white in color. After the reaction, lead oxide is formed, which is yellow in color. And after that, you'll see some fumes are being observed from the test tube. These fumes are of nitrogen dioxide gas. And at the end, you can see one more observation that the glowing splint reignites, which shows that oxygen gas is produced in the reaction. Okay. So ultimately, you can wind up with the equation, chemical equation, and you can write the chemical equation for the reaction taking place. So we will write lead nitrate. See, I have written the chemical name as well, lead nitrate. In the presence of heat, why we are saying heat? Because this is thermal decomposition. It forms lead oxide, which is yellow in color. Nitrogen dioxide gas is evolved, which is brown fumes, and oxygen gas, which can be confirmed by the third step, that is by reigniting the glowing splint. Or you can take any other material which can easily burn in the presence of, easily catch fire in the presence of oxygen. So this is 2 PbNO3 whole twice. Why I've written 2? Because of the balancing part. So I've taken lead nitrate. It was in solid form, white colored solid form. On heating, it forms PbO, lead oxide, again solid compound, which is yellow in color. Then we formed nitrogen dioxide gas, which are brown fumes, and oxygen gas as well. So I've written the physical state. This is the way how you people will write the balanced equation. So solid, in the presence of heat forms solid, PbO. Color is mandatory for these equations because sometimes roadmap questions or in long answer questions, what happens, long answer, we try to give you the color and we ask you to identify. It can be asked in 1 markers, what is the color of lead oxide, what is the color of nitrogen dioxide gas. So make sure you learn the concept, you understand the concept according to the color as well as the reaction which is taking place. So I guess the reaction is very much clear to all of you. Thank you for watching the video.